running at around 10 miles per hour, 15 or 20 miles per hour. Okay, at around 40 duration uh, time. The duration will be of 40 or 50 or 60, anything you can take. So what will be the grade percentage of the vehicle? Okay, so how much the grade should achieve that particular vehicle. So that particular suppose the vehicle is running at 10 kilometer per hour. Okay, so the grade percent should be there. Okay, the grade percentage of vehicle should be there. So that which will be found by using the gradability test. Okay, so the gradability test can be done using an advisor tool. Okay, so advisor tool which will be developed by NERL. Okay, that is an American government. So that is developed. We can so this what is this advisor tool? So we call it as a vehicle simulator or advanced vehicle simulator. We call it as it is used to set the data. Okay, it is used to set the model or script text file for use with a MATLAB and Simulink. So we are going to use same thing. We are going to use with a MATLAB and Simulink only. So that is not on different software. Kind of code has been developed in that particular advisor tool. Okay, so by running that code, we are going to generate an graphical user interface. So that is GUI will be displayed. So with the help of that window, we are going to perform different kind of tests. So only two tests are available in this. One is acceleration test, another is a gradability test. So anything you can do. Whether I'm going to show you the gradability test. Okay, and you are going to do both the things, gradability test as well as the acceleration test by using this tool. And different types of plots are we are going to generate by using this tool. Okay, it's a very simple tool. At around 70 to 80 MB zip file is available on the net. It's free of cost. You can download and you can run the code directly, or else I will provide on a VOLP. So just download it from VOLP and run the code inside the uh, MATLAB, so that directly you can perform the gradability test inside the MATLAB. So directly it is linked with the Simulink. Okay, it is linked with the Simulink. So predefined models are available in the this tool. Okay, suppose if you wanted to simulate an EV vehicle, so directly EV vehicle can be simulated by using this advisor tool. Okay, or if you wanted to take an hybrid vehicle, so you can do it with a hybrid vehicle also. If you wanted to do alone with a gasoline type of engine vehicle, you can do it with a gasoline engine also. So there are different parameters are available. If you wanted to change those parameters according whatever the given data. So if the given data is not there, then directly we can use the default data. Okay, and with that data only we are going to simulate. Over here we are going to see the energy storage system. Okay, suppose if a vehicle is having a 25 kilowatt of energy storage system in the vehicle, so how much the range the vehicle will cover. Suppose if I am testing for a drive cycle, okay, drive cycle, FTP drive cycle. Suppose if I wanted to run a vehicle at around 45 to 47 kilometer per hour, okay, so sorry, it has to cover the range of 45 to 47 distance. Okay, so what the energy storage is required of the vehicle. Okay, so if I am providing one drive cycle, what will be the distance it should cover? So for one drive cycle, we know that already we have seen for FTP, that is Federal Test Procedure. So at around 17.77 kilometer, it covers the distance by using a one cycle. If my target is 45 or 47 kilometer per hour, sorry, 45 to 47 kilometer range, so that is a distance. Okay, so how many number of cycles I required? At around 2.6 number of cycles I required. Suppose if I'm giving a 2.6 number of cycles, okay, so during that particular cycle, I am achieving that speed by using that how much the energy storage is provided in the battery, that much energy. By using that energy storage, I have to achieve that speed. If not, I have to increase my the energy storage inside the battery. Okay, So that is for the EV. If you wanted to consider, if you wanted to do it for gradability test for EV, you can do it. So otherwise you can do it for hybrid vehicle only. Okay, so I am going to show you. So matlab advisor tool provides a backbone for the detailed simulation of and analysis of the user defined drivetrain components. Okay, uh, so it is used to verify the data and algorithm from which you can take a full advantage of the modeling flexibility of Simulink, as well as analytic power of MATLAB. Okay, so the MATLAB is like very flexible software. Not only this advisor tool, so you can interface this Simulink, MATLAB Simulink, with the other software also. Okay, as I have designed the EV model in the MATLAB Simulink, so you can simulate that EV model inside the car sim also. Okay, so one of the software called car sim. So car sim is the one of the software. So in that also you can interface the MATLAB or Simulink, and you can simulate or you can test the model over there also in that software. So linking can be done with the other software. That is the power of MATLAB or Simulink. Okay, so we are going to do steady state handling in the car sim in the next practicals. Okay, so Carsim Sim is one of the advanced software nowadays. Now in the 2019-20 version, they have added these things. So like EV, all the EV configurations they have added, and all the hybrid electric vehicle components they have added in the Carsim software. So now today we use the advisor tool. Okay, so I'm going to share my screen. So entire screen I'm going to share. Okay, screen is visible, I guess. Screen is visible. Can anybody reply?
Yes, sir.
Okay. I have already opened the MATLAB, and so as I said, we are going to do with an advisor tool. That is a gradability test. Okay, so we are going to find out the grade percentage of a vehicle at a particular speed and particular time. Okay, so you can keep a time as a constant, or you can vary the time also. Better to keep a time constant time. Okay, so we'll consider a 40 seconds as a time. Okay, that is a constant time we are going to take, and we are going to vary the speed of the vehicle. Okay, and by varying the speed, what will be the grade percent, we are going to find out directly by clicking the run button. Okay, and we are going to see the energy table. Okay, what will be the usage of energy whenever it is in power mode and whenever it is in regenerative mode. All the data directly will be calculated by the tool. Okay, so how you are going to run the advisor tool? So that is not a big deal. Okay, just open. So wherever you have stored your file, just click on open, and so I have already in, so advisor I have downloaded over here. You can right click, and you can see the properties of that. So what is the maximum storage? That is at around 113 on size on disk. That is 113 MB maximum. So this much of tool which will give you a many different types of vehicles which is predefined in this tool. Okay, just click on that and you are going to run this code. Okay, which code you are going to run? So advisor MATLAB code you are going to run. So this is an advisor MATLAB code. Directly you are going to run this code. Okay, no need to study this code. Okay, don't think much about code and all, because just open that. So I have already opened that code. Okay, and after opening that code, you have to hit the run button. Okay, so when you hit the run button, so GUI window will be opened. Okay, that is graphical user interface window will be opened. From that you can proceed for the simulation of any vehicle, whether EV or hybrid or petrol or diesel engine vehicle. Okay, so any kind of vehicle can be simulated. So when you hit the run button, so GUI window will be open over here. So it will run the code and it will open the window. Just wait for a while. So this window will be opened over here. Okay, so whether you are going to use a metric unit, or you are going to use an uh, US unit. Okay, so NERL is the government of government which will be generated to simulate the parameter of the vehicle. Okay, just put it a start button, click on a start button. Okay, just hit on a start button. So it will run the code behind. Okay, no need to worry. So each and every parameter of the vehicle which will be displayed over here. So we have studied the pre-transmission as well as post-transmission. This is a layout for the pre-transmission vehicle, that is hybrid vehicle. Which type of hybrid vehicle it is, also torque versus speed has been given over here. This the graph of torque versus speed has been shown over here. You can study it from. So this is a fuel converter operation. Okay, and SI engine, that is a transient data, that is. So these are the parameters of the vehicle. So if you take, so here if you click in the load file, so there are different types of vehicles are available over here. So as we have seen the Toyota Prius vehicle in the theory lecture. So you can see out over here that Toyota Prius vehicle has been loaded over here. If you can see, there are many types of vehicles are available. If you wanted to consider an EV vehicle, so you can consider an EV vehicle over here. Okay, there are many types of vehicles are there. So whichever vehicle if you wanted to simulate, you can simulate. So just I wanted to show you for the EV. After that, we will go with the gradability test. So if you are select an EV vehicle, the layout will be changed. You can see this is how it changed the layout. Earlier it was gasoline engine, then battery pack, and then motor. After that, it is connected to the front wheel drive. Okay, so you can see battery pack is there and motor is there. Okay, so first we are going to see the speed of the vehicle. Okay, so at drive cycle 2.6, I am going to achieve the 45 percentage of 45 distance it has to cover. So first we will see that. Okay, here the battery energy storage is a 25 kilowatt. Okay, so you can see the scale components. So maximum power, peak efficiency, and the mass which is given in kg has been given over here. Okay, so you can change the cargo mass. Okay, so cargo mass can be changed over here. So it will automatically calculate the mass of the whole vehicle. Okay, so if you keep 500, so automatically it will change the cargo mass as 1508. Okay, and if you wanted to change to your configuration of vehicle, that is front wheel drive, and this is rear wheel drive, and this is four wheel drive. Okay, so any kind of vehicle you can select by using this. Okay, uh, after that you are going to test for drive cycle. Okay, so if you wanted to change the transmission type, okay, manual transmission is there, there are auto and CVT transmission is available. So type of transmission is a 5-speed transmission. Okay, and so motor type is given over here. There are different types of motor. Controller type has been given. So AC 75 kilowatt of motor power is there. Okay, wheel axle assembly can be changed over here. Okay, there are different parameters are there, you can change and you can proceed for the simulation. If you wanted to see the block diagram, you can click it over here. You can see the block diagram of the vehicle. It directly it will directed to the Simulink environment. Okay, so in the Simulink environment, whatever we have created the EV design, so same kind of design which will be shown by the dog block diagram. Okay, just continue over here. Okay, so here I'm going to take it as a FTP cycle. So you know that what is FTP cycle. So distance covered by one cycle by using this FTP. So you can see frequent start and stop will be there. This cycle is basically used for the urban driving. Okay, that is the city driving, because you can see speed and time, speed versus time. You can see frequent start and stop will be there in this graph. Time is constant for this ड्राई साइकिल दैट इज 2477 सेकेंड, ओके, डिस्टेंस कवर्ड इज 17.77। अगर एक साइकिल में 17.77 किलोमीटर डिस्टेंस कवर कर रहा है तो मुझे आई विल हैव अ टारगेट ऑफ 45 to 47 kilometer I have to run. So I have to change the number of cycle over here, so I will change number of cycle as 2.6. Okay, 2.6 I am going to change the number of cycles. So by using 2.6 number of cycles I am going to get around 45 or 47 uh, speed. Okay, so if I am not getting, then what is the drawback we are going to see over here? Okay, so we will do this gradability test later on. So just click on the run button. Okay, you can see over here I have given a 2.6 kilometer, 2.6 cycles. In the 2.6, it has to achieve the distance of how much? 45 to 47. My target is. So 17 to the how much? So that much double of that. Okay, so and 7.6 will be at around 45 to 47 it has to achieve, but it is achieving 41.4 kilometer. So warning message will be there, Mr. Trace by 2 miles per hour, that is 3.2 kilometer it is not covering. So why it is not covering? You can see the ess underscore soc underscore history, that is it is discharging the battery at this particular position. Okay, so this much of cycle it has been not running this only over here. It has been, the battery is fully discharged, only it is able to run at around 41.4 kilometer of distance. So our aim is to achieve the 45 to 47, okay, 45 to 47 kilometer of distance. So in that case, what is the drawback over here? The battery has been discharged at a 41.4 kilometer. Okay, so 41.4 किलोमीटर में आपका बैटरी डिस्चार्ज हो गया, तो यहाँ पे absolute average difference is 0.1598 miles per hour. Okay, and percentage of time with the trace missed greater than is 2 miles per hour has been it has been given over here, that is 3.2 kilometer per hour. How you are going to achieve this 47 kilometer? Just back to, and you have to change the energy storage value. Okay, so energy storage value I'm going to change to 35. So that's 35 kilowatt. So now we are going to run this. You can see the cargo mass is changed when I change the uh, uh, parameter of energy storage. You can see again I'm going to run it for 2.6 cycles, number of cycles. Okay, and run the simulation. Now you can see, so 47.5 I am getting over here. So now you can see the state of charge over here. So state of charge is still, it is in charge, it is in a little bit of in a charge condition, say at around 20-25%. At this particular uh, power or energy storage, I am going to get a 47.5 distance. Okay, so now you can see there is a it is achieving that particular drive cycle. Okay, achieving that particular drive cycle, that is 2.6 drive cycle. You can try it for 4 or 5 drive cycle. What it will happens, it will not achieve, I guess. Okay, so consider for different drive cycle, that is 5 drive cycle or 6 drive cycle, 6 number of cycles. So whatever the distance it should cover, it will not cover, because the drawback is the energy storage over here. Okay, so you have to change the energy storage so that the distance can be increased over here. So you can analyze over here what is the percentage of battery is required to achieve or that much of distance by the vehicle. So only I have selected over here electric vehicle, so that's why the emissions, then there is no emission over here. You can see in the green tab. Okay, so there is no emission, 000 values over here, it has been shown over here. Okay, just have shown you this how to achieve the distance of an electric vehicle when so analyzing the distance of a vehicle. So now actually we are going to our now practical, that is the simulation of gradability of an hybrid vehicle. So I'm going to select an hybrid vehicle, that is a parallel underscore default underscore in. Okay, this is an hybrid vehicle. You can see the layout of the vehicle has been changed over here. Okay, so gasoline, this is motor or generator. Okay, and so if you wanted to change the drivetrain configuration, you can change the drivetrain configuration to series, parallel, or fuel cell, or price GBN, or so these are the different types of vehicles are there. Conventional vehicle. Okay, and custom also you can take it over here. Okay, series, if you wanted to change to series, so this vehicle has to be changed to the series configuration. Okay, so you can see the this is our pre or post transmission. So now you can see the layout has been changed over here. Okay, now we will do it with a parallel itself. Okay, so we'll go with a parallel. So I'll keep it as it is, whatever the parameter has been given in this. Okay, so I'm going to keep it as it is. So for the fuel converter, uh, power will be 41, and energy storage I'm going to keep it as it is, that is 25 kilowatt, and motor controller power which will be of 75, and this is an efficiency. Okay, this is also for a 5-speed transmission which will be used over here. Okay, so I'll just change the cargo mass as a 500. Okay, so it will calculate automatically. Okay, but if you wanted to change the rear wheel drive, or you can change, or front all wheel drive, you can change the type of drive, you can change it over here from this. Okay, so just continue over here to do it a gradability test. Okay, this is a type of pre-transmission. So I'll go by FTP cycle only. फिफ्थ चैप्टर में ड्राइव साइकिल के बारे में थोड़ा सा पढ़ेंगे हम लोग, ठीक है. So FTP, so I'll keep it as 2.6 only. So that is the speed doesn't matter over here. So we are going to do it with a test, this gradability test. Okay, so just check mark over here the gradability test. So what you are going to do, you are going to form a table over here. Okay, so how you are going to form a table? First column is of serial number, second column is of your speed in miles per hour. Okay, third column is speed in kilometer per hour. Okay, fourth column is duration, fifth column is gradability percentage. Okay, so this you have to do it. First I'm going to show you at a speed of 10 miles per hour how much percentage of grade we are going to get at 10 miles per hour, and duration of 40 second. Okay, 40 second duration में 10 miles speed में हमको gradability percentage कितना मिलेगा. Okay, so we are going to uh, note down that reading. Okay, and then second I'm going to show you for 15 miles per hour. Okay, uh, for one speed you're going to plot all the graphs automatically. The graphs has been plotted over here, no need to worry. And for one particular speed you're going to plot your energy usage table. Okay, that also be directly it has been calculated, and it will be formed. Okay, automatically it will be formed in this software. Okay, and just gradability test, click on a grade option. So in the grade option you can see these are the advanced options are available over here. We are going to do the test for speed and we are going to do the test for duration. So first I am going to change the speed to 10. मतलब आप लोग क्या करना पड़ेगा यहाँ से 10, 15, 20, 25, 30, 35, 40 up to 100 you are going to do number of speeds. Okay, so for each and every speed you are going to uh, note down the percentage of gradability. So keep a constant value of 40 seconds. Okay, 40 seconds I'm going to keep a 40 seconds as a constant value. Okay, so you can enable or disable the system. So energy storage system can be disabled, or fuel converter can be disabled over here, or this can be disabled, but I'll keep it as all system enabled and in enabled condition. Okay, so all system in enabled condition. So third thing is a mass parameter. So mass parameter, already we have given a cargo mass of 500. The vehicle mass has been calculated. Whole vehicle mass has been calculated. That is 1714. Okay. If you wanted to add add to the current mass, whatever the current mass is there, so if you wanted to add some mass, extra mass over here, you can select this option to add an extra mass. These are the solution condition. If you wanted to keep your grade percentage between 0 to 10, you can consider 0 to 10, or else you can directly you can put the display status. Okay, display status you can put it. You can keep 50, or you can keep 100. Okay, according to that your gradability percentage will be displayed over here. Okay, so and if you wanted to consider an grade tolerance in percentage, you can consider your grade percentage in tolerance also. So these are all the solution condition. Grade lower bound will be 0, and it starts to simulate grade percentage from 0. If you consider up to 10%, it will consider only 10% only. Okay, if you consider 100%, if you the grade percentage will be simulated up to 100%. Okay, so what will be the percent? It will be directly indicated with the test results directly. Okay, so I'll keep it this only. Display status as 100 I'll keep. Okay, so 100 I'll keep. So according to the 100 value, which will give you an grade percentage. Okay, so okay, so these are the value. If you wanted to change different values, you can try it out with the different values also. So run over here. So if you run this, it will run for some iteration. Okay, so I'll hit a run button. Okay, you can see over here 17.77 kilometer is your distance. What will be the maximum speed? Maximum speed is 91.25 kilometer per hour. Average speed is this much. Maximum acceleration is this, and maximum deceleration is this much. Okay, so average acceleration, average deceleration, idle time, then no number of stops. Okay, in this drive cycle, how many number of stops has been indicated over here? 22 number of stops are there. Okay, so maximum upgrade, maximum average upgrade, it has not been considered. That's why it is indicating as 00. Just hit a run button. You can see over here it is running from 0% grade at a 10 miles per hour. Okay, so trying to achieve 1% grade at 10 miles per hour, trying to achieve 3.618 percentage at 10 miles per hour. So whichever grade percentage is suitable, that will be that value will be given to you. Okay, that percentage, that much of percentage is suitable for that vehicle at 10 miles per hour. Okay, so it will run for a number of iteration, and it will find out that which grade percentage is suitable for the vehicle at 10 miles per hour. Okay, so you need to note down all the values. So from starting from 10 miles per hour to 100 miles per hour. Okay, पाँच 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 इंक्रीज करते जाओ, और आप ग्रेड परसेंटेज वैल्यू नोट डाउन करो एक टेबल में. Okay, it has been displayed. You can see we got around so 10 miles per hour means that is gradability at 16.1 kilometer per hour. Okay, so we got around 50.4 percentage of grade value. So we have not considered an acceleration test. Acceleration test are written as not applicable. So if you wanted to consider an acceleration test, that also you consider, and you can get the values of all the acceleration parameters. Okay, so how you are going to write down in the table? So in the first serial number, you are going to write in the kilometer, in the speed per vehicle speed in miles per hour, that is 10 miles per hour. In the second column you have to write down kilometer per hour, that is 16.1 kilometer per hour. In the third column you are going to write down 40 second, the duration of the vehicle, and in the last column you are going to write down this 50.4 percentage of gradability value. Okay, so if you are going to generate an energy usage table, so just click it on energy usage table. So you can see the energy storage table has been generated over here. Okay, and the power mode and regenerative mode energy has been used over here. Okay, so these are the value has been displayed over here. What is the energy in, what is energy out, what is the loss, and what is the efficiency. Similarly for regenerative mode also. So loss plot I can create by clicking on the loss plot. So these are the loss plot, energy usage in the power mode. So uh, this is a loss plot, and this is the loss for the regenerative mode. Okay, so this is loss for the regenerative mode. So this graphs has to be developed, or this table has to be developed for one particular speed. Say I am going to give it 50 miles per hour. In the 50 miles per hour you are going to generate all the graphs, and all the energy usage table also you have to uh, generate. Okay, fuel converter also it has been given. So how much energy has been in, and how much energy has been utilized, and what will be the loss, and what will be the percentage of efficiency. Okay, so you can see the efficiency of fuel converter, you can see only 25% of efficiency you can see it over here. And if you see an energy storage efficiency, you can see at around 0.86 percentage of efficiency there. So the that is as compared to the, as we have studied in the lecture also, as we have know that 25% of efficiency which will be got from the gasoline engine, so as compared to the electric motor. Okay, so this has to be generated. Okay, and you can see the emission standards. So emission has been generated over here by seeing this graph. You can read out the emission, how much emission has been generated over here. Carbon dioxide, NOx. Okay, it has been generated. If you wanted to see, if you want to see the standards, what will be the emission standards, you can see. Nowadays BS 6 standard is going on in the market. Okay, so if the emission standards has been, if will increase in the future days, so BS 6 to BS 8 आ गया समझो कि it's difficult to achieve by using an conventional vehicle, that is petrol or diesel engine. So इस बहुत ही difficult होगा. तो in that case क्या करना पड़ेगा, hybrids, it has to be switched to the hybrid, or they have to switch to the electric vehicle. So that's why मतलब अगर ऑप्टिक कंबशन चेंबर को ऑप्टिमाइज करना है तो इट्स वेरी डिफिकल्ट टू ऑप्टिमाइज. एंड इफ he succeed to optimize, then also the cost of that is very higher, and cost of manufacturing of that combustion chamber is very higher to achieve the whatever the standards has been provided by the government. Okay, so this output plot control अगर आपको generate करना है तो just click on a output plot control. It will generate a number of plots, torque versus speed. Just read out these graphs. Okay, and vehicle speed versus time. Okay, so it is a difference between requested and achieved speed, what I have requested and what the achieved speed will be there. Okay, and this next graph is a fuel converter efficiency, that is efficiencies versus time. Okay, then motor or controller efficiency. Okay, in driving only, not in regenerating the regeneration mode. Efficiency versus time. Okay, and this is for the gearbox efficiency, driving only, not in the regenerating mode. Efficiency versus time has been shown. Okay, then efficiency versus time, whenever the energy storage system is efficiency while charging. Okay, and the energy storage system efficiency while discharging. This is a graph which will shown by you. There are number of graphs can be generated by using this advisor tool. So let us try for 15 miles per hour. Okay, how much the gradability percentage we are going to get by using a 15 miles per hour. Just pack karo ek. Okay, just click on a grade. Okay, I'll change it to 15 miles per hour and click OK and just run. Gaurav Bhosle is asking, tell them to join. Gaurav and one more is asking for the permission to join. Okay, now it has been. I'll allow him to join. Just tell him to join now. Almost it is over only. Practical. Let it be. ओके, यहाँ पे देखो कितना आ गया अपना ग्रेड परसेंटेज. ग्रेड परसेंटेज आ गया अपना 46.5% आ गया. ठीक है, 46.5% आ गया. तो आप यहाँ पे सिमुलेशन डेटा और टेस्ट डेटा भी कंपेयर कर सकते हो. देयर इज नो वार्निंग मैसेजेस शुड नॉट बी देयर. ओके, so energy usage table you can see. So I'm getting over here how much, 46.5%. At a distance it is covering how much. So I am giving a 2.5 number of drive cycle. I'm getting 47.5. So you try it for different drive cycle. Okay, so you can use it for 3 drive cycle, 4 drive cycle, 5 drive cycle. You can try it for different drive cycle. So gasoline equivalent is 7.5 over here, and the emissions it is giving some emissions. Then also it is both the power modes are using, so gasoline as well as electric power mode using over here. So energy storage, if you can see, energy storage system, this is an energy storage system. Overall efficiency can be calculated by using this formula. Okay, so overall efficiency can be calculated. So you can plot the graph, all the graph, by using this. So you can see this graph is shown by you. It is shown the state of charge. It will be discharged when the vehicle moves over a period of time. Okay, So I'm going to upload this advisor tool. Okay, then you're going to do this software and do this practical. Okay, if you have any queries, you can ask. Okay, see, from the next week we are going to conduct the continuous evaluation for the practicals. Okay, all the practice. So one practicals, whether it is oral or whether it should be oral. Okay, it will be oral. So, possible. If not possible, I'm going to take it on Google Form. Otherwise, it is oral. So complete all the practicals from the starting. Okay, all the practicals uh, I have uploaded on a Vivo LP. Sample files also I have uploaded. .slx files, that is not Excel file. Okay, so that is an your assembling file, so that you can refer and you can complete your practicals. Okay, and this practical today I'll upload, and you're going to do it. It's very easy. It can be done within 15-20 minutes. So you complete this. After that, you can complete the previous practicals. If from the next week we are going to conduct the continuous evaluation tests. Okay. So we will stop over here. So by today evening, I am going to upload this recording as well as the advisor tool. So do it. Okay. If you have any query, you can ask. Otherwise, we'll wind up the practical. No doubts. Just put your attendance in the chat box.